All right, so uncertainty is a huge component of your internal assessment. It's very important in IB chemistry. It's not very important in AP chemistry, but it is important in IB because it's tested in all three papers. It's also a huge part of your internal assessment. So before we can talk about uncertainty and how we deal with uncertainty in measurements, we have to talk about significant figures. So we've already discussed significant figures, so we're just going to quickly review that. So with the data, it can either be qualitative or it can be quantitative. So qualitative data would be something like the color of something, the texture of it, whether it's hard or soft. Quantitative data is going to be associated with a number, and it will be obtained from taking a measurement. So since we're taking a measurement and we're using some sort of device to do that, there is uncertainty and random errors associated with each measurement that we have. So when we round in science, we look at significant figures. When you're in a math class, you don't really care about that because typically with math, you're not really dealing with measurements, but in science you are. So when we are counting in a digit, when we're trying to count the number of significant figures, we count all numbers as significant for rounding except for leading zeros, the zeros in front of a number, or trailing zeros without a decimal point. So for instance, the first number right here, we have, let's see, we have 1, 2, 3. These are all leading zeros, even the ones that come after the decimal point. They are all leading zeros, so it's one significant figure. This number, well, we have 2 trailing zeros, and there's no decimal point. So the only number that gets counted as significant, it would be the first one, so that's also one significant figure. When I look at this one, well, it's the same number, it's 300, but there's now a decimal point. So it would be, even though we've got 3 trailing zeros, we count all of them because there is a decimal point, so it's going to be 4 significant figures. For this number, well, we have 1, 2, 3 leading zeros, and then we have a trailing zero, but we will count the trailing zero since there is a decimal point. So 1, 2, 3, 4. 4 significant figures. All right, so let's go ahead and round each of these numbers to 3 significant figures. So what we do is we go to the third significant number in the digit, and let's see, we go 1, 2, 3, and we look at the number behind it. So it's a 9, that means it rounds up. If it's 5 or above, it's going to round the number up. So it's going to be 3.2, and 8 would round up to a 9 here. So 3.29. And that's 3 significant figures. So now we look at this one. Well, this is not significant, nor are any of these zeros. So we go to the third significant number, which is 1, 2, 3. It's the 6. There's a 7 behind the 6, so the 6 gets rounded up. So leave the zeros there as placeholders. So 3, 5, 7. And that's 3 sig figs. So now let's look at this one. I've got 1, 2, 3. The 5 is the third significant figure. There's a 1 behind it, which means that the 5 will stay a 5. So it's 305, but I can't just round it to that. I will leave a 0 as a placeholder. So now this one, okay, so we go to the third significant number, which is a 0. There's a 1 behind it, which means it stays a 0. But if I write it as 3,000, that's only one significant figure. So if I want to have it as 3 significant figures, I'm going to put it in scientific notation. So it should be 3.00 times 10 to the third power. So in scientific notation, all of these numbers are considered to be significant. So if you come across something like this and you know it needs to be so many significant figures and you can't really round it like this, you have to put it into scientific notation. All right, so multiplying and dividing. So when you take your measurements and you're actually doing a calculation with them, you need to round appropriately. So for multiplication and division, you're going to round to the smallest number of significant figures. For addition and subtraction, you're going to round to the smallest place value. If you happen to have multiplication and division with addition or subtraction, then you have to round each time you use a different operation because it's a different rule, and then round again at the end. So let's do some of these. Okay, so the first one, we are dividing. So if you plug this into the calculator, you're going to get this number. Okay, so for division, we're going to go to the smallest number of significant figures. So this would be 1, 2, 3, 4, 5 significant figures. This one would be 1, 2, 3, 4. Well, the smallest number of significant figures would be 4. So I go to my fourth significant number, which is a 6 here. There's a 9 behind it, so that means it gets rounded up. So it's 315.7. Let's look at the next one. So addition. So addition, we look at the smallest place value. There are 2 decimal places here, 3 here. So this will get rounded to 2 decimal places. So I go to the second decimal place, there's a 3, and then there's a 3 behind that, so it stays a 3, so it's 4.13. All right, now we have a mixed operation one. So it's the same math here, just to keep it simple. So we know that we have a rule for division, we have another rule for addition, and then we also have another rule for multiplication here. And you have parentheses, so you will follow the order of operation. So we will go with our parentheses first. So I would do this operation and I would round it. Well, then I would round it to this. All right, the next one, I'm going to add them and then round it. I get this. And I've done the operation. I round it since I'm going to a new operation. All right, so now we have this. We have 315.7 times 4.13. All right, so if I multiply this is what I'm going to get. I'm going to get 1303.841. Well, now we're looking at multiplication, so we look at least number of sig figs. This is 4. Significant figures, this is 3. My answer has to go to 3. So I go to the third significant number, which is a 0. There's a 3 behind it, so it stays a 0. So it's 1300. But if I want to get it to 3 significant figures, I'm going to have to put it into scientific notation. So 1.30 times 10 to the third. 1, 2, 3. Okay.